For this lesson, we are going to calculate the volume of gas present given the number of moles or mass or volume of reactants or products from a chemical reaction. Okay, let's go to your page 13 of your notes. Okay, so I have the question here, 3a. Methane reacts with steam to form hydrogen and carbon dioxide as shown below. Here's the balance equation. So what volume of hydrogen can be obtained from 100 centimeter cube of methane at the same room temperature and pressure? Okay, so firstly I highlight you have this situation when volume of gas is provided. Okay, let's highlight volume of gas is provided, which is methane. Okay, I highlight blue for methane. Methane is CH4. Next, you are needed to find volume of hydrogen. Hydrogen, okay, let me highlight the hydrogen. Hydrogen is this one, H2. So firstly, first step, I always ask you guys to write the ratio, right? If you remember, so please write the ratio CH4 to the ratio of 3H2. Okay, first row here, you need to write the number of moles from the equation. Here, number of moles of CH4 is 1. Number of moles of this hydrogen gas is 3. So next step, you need to get the volume. What volume is this? Volume from the number of moles. So 1 mole of the gas. Okay, next step is volume. So what volume is this? This volume we get from the number of moles. Since the unit given here is centimeter cube, so we're gonna use the centimeter cube here. So let's get the volume. As you recall from the previous lesson, 1 mole of any gas should be equal to 24 dm cube or 24,000 centimeter cube. So since this is centimeter cube, we are going to use the 24,000 centimeter cube. So for this case, if 3 moles of the gas should contain 3 times 24,000, so you get 72,000 centimeter cube. Alright, now the next row, you are supposed to put the volume given from the question. So given from the question, 100 centimeter cube of methane. So you put below methane, which is here 100. So what is the volume of hydrogen? So you put the X. So now let me recall again, yeah, this volume, especially this one on the second row, is from your number of moles. So maybe I should put here molar volume. As you know, molar, right? Volume, molar. So I hope you guys remember this. This one you need to convert. 3 moles convert to this, 1 mole convert to that. Okay, so next step, after this, you guys remember what to do next. Focus on this 4 stuff here. Then you do your cross multiply. So let's do your cross multiply. Yeah, I hope you guys remember how to do cross multiply, yeah. Then bring this to other side, becomes division. So leaving the X alone. So therefore 100 times 72,000 divide with 24,000. So you do the calculation, then you should get 300. Cancel this 0, cancel this 0. 72 divided with 24, you get 3. So 3 times 100 is 300. What is the unit for this? So if you notice here is cm cube, cm cube, cm cube. So here should be cm cube. So your answer should be centimeter cube. We conclude here. So first step, write down the number of moles from the equation you got. Okay, so after you write the ratio, you have to write the number of moles here, 1 to the ratio of 3. Okay, next step, you need to convert the number of moles to volume. This one, the second step. So from the number of moles you got here, for example 1 mole, you convert to the volume. According to the question, you need in centimeter cube. So 1 mole of any gas should be equal to 24,000 centimeter cube. So if 3 mole of the gas should be equal to 3 times 24,000, you get 72,000 centimeter cube. Okay, step 3, you place the given volume to the appropriate box. Okay, the given volume on the question is this 100 centimeter cube of methane. So you place this 100 underneath this CH4 here. Okay, so the unknown, the volume of hydrogen, so you put as X. Alright, step 4, the final step, you cross multiply to find the X. You just focus this box here, then you cross as usual, do your maths, and finally you get the value X. That's all. Okay, next question, 3B. When you have 0.1 gram of magnesium is treated with an excess hydrochloric acid, what is the volume of gas will be produced at this room temperature and pressure? So I highlighted here, when the mass is provided, you are asked to find the volume of gas produced. So from this equation, this gas is produced, right? This is hydrogen. Okay, so let me write down. This is solid, this is aqueous. Your magnesium chloride should be aqueous, then this is the only product, this is the gas. So let's highlight those two stuff you need to focus on. Magnesium, this is the given one, magnesium, I highlighted as yellow. Then what is the volume of gas? You are asked to find this, so I highlighted it as blue. So let me highlight this hydrogen blue also. So as usual, you write down these two into the ratio form. Mg to the ratio H2. First step, as I told you, firstly write down the number of moles here, number of moles. So number of moles of magnesium is 1. Number of moles of this hydrogen gas is 1. Next. Alright, so for this next row, we usually write the AR or MR or the molar volume of the gas, right? So for this case, since the magnesium given here is mass, so we need to convert this 1 mole of magnesium to the atomic mass, which is the AR. Yeah, mass for magnesium from your periodic table is 24. I put here gram. So for this case, the volume of gas, the gas here is hydrogen, so here must be written for the gas. 1 mole of any gas is equal to 24 dm cube, or even 24,000 centimeter cube. For this case, I'm going to use the 24 dm cube. So let me write here. Here, the magnesium, you're supposed to get the mass. Here is the volume, because you are required to get the volume of hydrogen. So here, this one should be the MR, or even the volume. Next, you need to put down the given value. Given value for this case is the 0.1 gram of magnesium. So you put here 0.1 gram under magnesium. Volume of gas, you don't know the volume of gas, so you put X dm cube. Please notice that the units here from one column they are the same. Do you notice here gram and gram? Then you have here dm cube and dm cube. So when you do your cross multiply, the units can be cancelled out easily. So your next step is to do cross multiply. So cross multiply as usual. 0.1 bring to the right hand side, the x bring to the left hand side. X times 24 equal to 0.1 times 24. So the 24 you bring to other side becomes division. Then 0.1 times 24 divide with 24. So same unit, no, not same unit, same number, cancel each other, you left with 0.1. X is 0.1. What is this unit? Please write down the unit. This is dm cube. So let's recall our steps here. First step, write down the number of moles from the equation. Okay, take the two important things, then write into ratio, then write the number of moles accordingly. Second step, I wrote here, you notice that the H2 as in volume. Okay, as in volume. So you need to get the volume of 1 mole of the gas. If here is 1 mole, you need to convert to dm cube. 1 mole of any gas is equal to 24 dm cube. Meanwhile, on the left hand side here for magnesium, you notice the magnesium given here is in gram, which is mass. So you need to get the AR, the atomic mass, for 1 mole of magnesium. Since here is 1 mole of magnesium, so 1 mole of magnesium is equal to 24. Okay, step 3, put in the given value accordingly. So for this case, you are given 0.1 gram of magnesium, so the 0.1 gram must put underneath the magnesium column. Alright, step 4 here. So you need to cross multiply to get the value of x. So here's the box you need to focus. So let me zoom. This is the things you need to focus for your cross multiply, yeah. Then yeah, do your arithmetics, your maths, then you get the final answer, which is 0.1 dm cube. Alright, the next question is on your notes, page 14, question 3i. Sodium reacts with water according to the equation below. You have this balanced equation here. So the question here is, what is the volume of hydrogen produced in room temperature and pressure when 0.2 moles of sodium reacts? So here I have highlighted here, when the number of moles is provided. So what would you do if the number of moles is provided? Okay, first thing first, take the two important things from the equation. So let's use the highlighter. Okay, so I highlight the yellow one with sodium. Then you are asked to find volume of hydrogen. So let me highlight it in blue. So these two things you must write into the ratio form as usual. 2Na to the ratio of H2. So first step is always the same. Please write the number of moles. Number of moles. Here you have 2 to the ratio of 1. Alright, next step. Since the given volume, since the given value here is 0.2 moles, and fortunately that here is moles and moles as well, so we just gonna put the moles into the column underneath sodium. Alright, since for this case you are provided with 0.2 moles of sodium, and fortunately here is already in moles, yeah. So you just might as well just put the 0.2 moles of sodium here. So here the next unknown should be x. X what? X mole. Because why? Here is already mole, right? So let me write here for clarity. This is mole. This is mole. This is mole, right? From your question, 0.2 mole. So your unknown also has to be in mole. So as usual, you have seen this as always. When you have x, you just cross multiply. So cross multiply, 2 times x is equal to 0.2 times 1. So the 2 you bring to other side, becomes division. So 0.2 times 1 divide with 2. So do your maths. 0.2 divide with 2, you get 0.1. So x equal to 0.1 mole. Have we finished this question? No. The question is we want volume. How do we get the volume? How do you convert moles into volume? Remember the triangle? As we learned in previous lesson, this triangle, here's the number of moles, here's the volume, here is 24 dm cubed. If here is 24 dm cubed, here should be dm cubed as well, right? Alright, so you are required to find volume, right? So let me highlight the volume in this blue as well. So you know your number of moles is 0.1 mole. Here is 0.1 mole. So what's the volume? So by formula, this triangle, number of moles times with this 24. So volume is equal to number of moles times 24 dm cube. You can use centimeter cube as well, but it has to be 24,000 centimeter cube lah, huh? For easiness, I just gonna use 24 dm cube. So 0.1 times 24 dm cube. So when you multiply, you should get 2.4 dm cube. Please put the units, and here you go. Okay, let's recap our steps today. So for this situation, when you have number of moles is provided, so as usual, first step, take the two important things from the question, put down into a ratio form. First step, write down the number of moles from the equation to the ratio of 1. 2 moles the ratio of 1 mole. Second step, since the 0.2 moles is given here, might as well just put Tarus to the equation. So step 2, put the number of moles given to the correct box. So this 0.2 belongs to the sodium, so please put properly. So the unknown is the hydrogen, so it has to be moles as well, so you just put x. So the third step, you must do cross multiply. Focus on this, the 4 things here, then you do your normally cross multiply to find the unknown x. Yeah, so you get 0.1 mole. Okay, so you haven't finished the mole, you need to convert to volume. So how do you convert this mole to volume? So you have step 4, convert the number of moles to volume by using this triangle. Please remember this by heart. So since this question do not require either you want dm cube or centimeter cube, so I prefer this dm cube because the number is smaller, 24 dm cube, that's the magic number. So volume is equal to number of moles times 24 dm cube. So just substitute this 0.1 mole into n, then you get 0.1 times 24, you get 2.4 dm cube. Okay, that is the answer. So what's our step to success for this part of the topic? So make sure you have selected 2 correct things from the balance equation. Okay, 2 correct things or 2 important things from the equation. Next, write down the number of moles from the balance equation, right, in the ratio form. If you are given with mass, get the MR or AR from the periodic table. If you're given with volume, so just use the magic number. 1 mole of any gas is equal to 24 dm cube or 24,000 centimeter cube. If you have 2 moles, so just multiply with 2. If you have 3, just multiply with 3. Okay. Next, put the given value accordingly, according to the whichever space, yeah. Then you do cross multiply. Don't forget to put x as unknown. Put x as unknown. Put x for unknown. Then you do cross multiply. So if your answer is in mole, convert to volume. Either you use this triangle, the one with dm cube. If you need in dm cube, it has to be 24. If you need in centimeter cube, you have to use the 24,000. Okay, that's all for today. So if you have any question, please personal text me.